The artillery had stopped 3 hours ago, but the ground still trembled. Or maybe that was just his hands. Carl Schmidt stood at the edge of a makeshift repair depot somewhere outside Anzio, watching 4 soldiers drag something through the mud. The Italian spring should have been beautiful. Instead, the air tasted like cordite and diesel, and the sky hung gray and indifferent over what remained of the village square. The thing they were dragging was American. A half-track captured intact from an ambushed convoy that morning. Its olive paint was scratched, one headlight shattered, but otherwise the vehicle sat there like a puzzle waiting to be solved. Schmidt pulled his coat tighter. He was not a soldier. He had never fired a weapon in combat. His war was fought with calipers and micrometers in the sterile silence of engineering bays far from the front lines. For 15 years, he had worked in Daimler-Benz factories, building engines that represented the absolute pinnacle of German precision. He had dismantled British Crusaders and Soviet T-34s, cataloging their weaknesses with the clinical satisfaction of a surgeon examining a lesser colleague's work. But something felt different today. He could not explain it. Call it instinct. Call it the way the commanding officer had handed him the assignment without meeting his eyes. "Open it," the officer had said. "Tell us what makes it work." Simple enough. He had done this dozens of times before, so why did his hands refuse to stop shaking? Here is something most people never consider about World War II. We remember the battles. We remember the names of generals and the dates of invasions. But wars are not won by bravery alone. They are won by factories, by supply chains, by the relentless mathematics of production. And in early 1944, those mathematics were beginning to haunt German high command like a ghost they could not explain. Think about it this way. Germany was bombing Allied convoys. U-boats were sinking supply ships by the dozen. The Atlantic should have been a graveyard for American equipment. And yet every week more vehicles appeared on European soil. Not just more. Impossibly more. Trucks destroyed at dawn were replaced by nightfall. Tanks knocked out in Monday's battle reappeared in Tuesday's assault. The numbers made no sense. German intelligence had a theory. American equipment must be simple, primitive, easy to manufacture in bulk but inferior in every meaningful way. This was the comfortable explanation, the one that let officers sleep at night. Schmidt had believed it too. He was about to discover how dangerously wrong that assumption was. The engine compartment opened with a reluctant groan. Schmidt leaned in, his flashlight cutting through the shadows, and immediately felt a familiar wave of disappointment. The welds were rough, unpolished, almost careless. Bolts sat at odd angles. Nothing aligned with the geometric perfection he was trained to expect. In a German vehicle, every component existed in harmony, machined to tolerances measured in hundredths of a millimeter. This looked like it had been assembled by workers who had never heard the word precision. He pulled out his field notebook and began writing. Construction appears hasty, excessive clearance throughout, no evidence of finishing work on non-critical surfaces. He almost smiled. This was exactly what the intelligence reports had predicted. American manufacturing was crude, built by factory workers who treated engines like disposable appliances rather than works of mechanical art. Then he removed the first bolt. It came out too easily. No specialized wrench required. No careful alignment, just simple, direct removal. He tried another, same result, then another and another. Schmidt stopped writing. In a German engine, components were married to their specific vehicles, each part machined to fit one location and one location only. Removing them required expertise, patience, specialized tools. But these American parts seemed almost eager to be removed, as if they expected it. As if someone had designed them knowing they would need to be replaced quickly in the field by hands that might be frozen or injured or simply untrained. That was not sloppiness. That was intention. And the difference between those two things would keep Schmidt awake for the rest of his life. Let me ask you something. What do you think matters more in a war? Building the perfect weapon or building enough weapons? It seems like an obvious question. Of course, quality matters. A superior tank should defeat an inferior one. A precision engine should outlast a crude one. This is logical. This is rational. This is also exactly how Germany lost. Schmidt moved deeper into the engine bay, and what he found there shattered everything he thought he understood about mechanical engineering. The power plant was a white 160 axe, a gasoline engine producing roughly 147 horsepower. By German standards, pathetically weak. German tanks boasted engines twice as powerful, capable of speeds and maneuvers that would leave American vehicles choking in their dust. But Schmidt noticed something strange. The compression ratio was deliberately low. The tolerances were intentionally loose. Components that German engineers would have machined to microscopic precision were oversized, almost crude. Why would anyone do this on purpose? The answer came to him slowly, then all at once. This engine could run on terrible fuel. The low-grade, impure gasoline that German engines would choke and die on, this American power plant would drink without complaint. It could operate in dust storms and mud pits and frozen wastelands. It could survive neglect, abuse, inexperienced operators who had never seen the inside of an engine before being drafted 6 months ago. German engines demanded perfection, perfect fuel, perfect maintenance, perfectly trained mechanics. This engine demanded nothing. It simply refused to die. Schmidt sat back on his heels, and for the first time in the war he felt something cold settle in his stomach, because he suddenly understood that he was not looking at inferior engineering. He was looking at a completely different philosophy of war. There is a story that Schmidt would tell years later, after the war had ended and the ruins had been rebuilt and the world had moved on. He never published it, never spoke of it publicly. But in private letters to fellow engineers, he returned to this moment again and again, like a man probing a wound that never fully healed. The story was about the frame. German vehicles used precisely machined components for structural elements, each piece milled from solid steel, polished, fitted with the care of a watchmaker assembling a timepiece. The process was beautiful. It was also extraordinarily slow. The American half-track used castings. Molten metal poured into forms, cooled, drilled, installed. The technique was faster by orders of magnitude, but German engineers avoided it for critical components. Castings were unpredictable. They contained microscopic variations. They offended the very idea of precision. And yet, when Schmidt calculated the time required to build one American half-track versus one German equivalent, the numbers broke something inside him. 8 hours. A single American half-track could be assembled in under 8 hours. German vehicles required days, sometimes weeks, not because German workers were slower, but because German philosophy demanded perfection at every stage of production. Every component checked and rechecked, every tolerance verified, every surface polished to mirror smoothness even if it would never be seen. The Americans did not care about perfection. They cared about speed. And in total war, speed was the only currency that truly mattered. The workshop door creaked open behind him. Fritz Keller, a younger engineer from the motor pool, entered carrying crates marked with American stencils, spare parts recovered from the same convoy that had yielded the half-track. "Found these in the wreckage," Keller said, setting the crates on a workbench. "Thought you might want to see them." Schmidt began laying out the components: carburetors, fuel filters, electrical connectors. Standard maintenance items, and then he noticed something that made him stop breathing. The carburetor fit the half-track, but when he checked the specifications, he realized it would also fit a standard American truck, and a light tank variant, and probably a dozen other vehicles he had never seen. The same part, interchangeable across multiple platforms. In Germany, every vehicle had unique components. Custom engineered, custom manufactured, impossible to substitute. If a Panzer needed a replacement fuel pump, it required that specific pump made for that specific vehicle, shipped from that specific factory. But the Americans had built something different, something terrifying in its simplicity. Keller looked at the parts spread across the table. "What does it mean?" Schmidt did not answer immediately. He was thinking about factories, about supply lines, about what happens when a single facility is bombed. In Germany, if one factory went down, the parts it produced vanished from the supply chain. Vehicles sat idle, waiting for components that might never come. The whole system was fragile, dependent on perfect coordination between dozens of specialized manufacturers. But if American parts were interchangeable, if one component served multiple vehicles, if any factory could produce any part. "They did not build machines," Schmidt finally said, his voice barely above a whisper. "They built an ecosystem, and ecosystems do not have single points of failure." Now here is where the story takes a darker turn, because Schmidt was not just discovering uncomfortable truths about American manufacturing. He was discovering something far more dangerous. He was discovering that Germany could not adapt. Think about what would be required to copy the American approach. You would need to redesign every vehicle in production, retrain every worker, restructure every factory. Convince engineers to abandon the precision philosophy they had spent their entire careers mastering. And you would need to do all of this while fighting a war on two fronts, with supplies dwindling and factories being bombed and skilled workers being sent to die on battlefields from which they would never return. It was impossible, not difficult, not challenging. Mathematically, strategically, culturally impossible. Schmidt understood this with a clarity that felt like grief. He could write the most detailed report imaginable. He could explain every advantage the American system possessed. He could present irrefutable evidence that Germany was fighting the wrong war with the wrong philosophy. None of it would matter. You cannot redesign a nation in the middle of a war. You cannot improvise an industrial revolution. You cannot teach engineers to embrace imperfection when their entire identity is built on its rejection. The half-track sitting in that Italian workshop was not just a vehicle. It was a message from the future. And the message was simple. You have already lost. You just do not know it yet. Schmidt found a repair manual tucked beneath the driver's seat. What he saw inside completed his education. The manual was simple, absurdly simple. Diagrams instead of technical specifications. Step-by-step illustrations that a child could follow. Instructions written in plain language, assuming the reader had never seen an engine before. In Germany, military vehicles came with manuals that read like doctoral dissertations. Maintaining them required extensive training, specialized education, years of experience. This assumed a supply of expert mechanics that Germany possessed in abundance. But the Americans had built their manual for farm boys, for factory workers. For 18-year-old recruits who had been driving tractors 6 months earlier. Anyone could follow these instructions. Anyone could keep this machine running. And that meant the Americans could train new mechanics faster than Germany could kill them. Schmidt closed the manual and sat in silence for a long moment. Around him, the workshop felt suddenly small. The half-track loomed in the dim light, no longer an object of derision, but something far more unsettling. A revelation. He thought about his 2 sons, both serving on the Eastern Front, about his wife waiting in Stuttgart for letters that came less frequently now, about the future he had imagined for his family, for his country, for the engineering tradition he had dedicated his life to preserving. And for the first time since the war began, Carl Schmidt felt something that German engineers were never supposed to feel. Doubt. That night, by the light of a single lamp, Schmidt typed his report. He chose each word with the care of a man composing his own epitaph. American vehicles display no individual brilliance. Their engines are unremarkable, their construction is crude by our standards, their armor is thin, their weapons merely adequate, but their strength does not lie in any single component. It lies in the system surrounding them, in the interchangeability of parts, in the speed of production, in the simplicity of maintenance, in the philosophy that embraces good enough over perfect. Replicating this approach is theoretically possible but practically impossible under current German industrial structure. Our factories are optimized for precision. Our engineers are trained for perfection. Our entire philosophy of manufacturing runs counter to what the Americans have achieved. We are not losing to better machines. We are losing to a better idea. Schmidt paused over that final sentence. He knew what would happen when Berlin read it. Denial. Dismissal. Perhaps accusations of defeatism. The truth was not something the high command wanted to hear. But he wrote it anyway, because somewhere buried beneath the pride and the propaganda, he hoped someone would understand. The war was no longer about tanks and planes and artillery. It was about time. And America had more of it. History would prove Schmidt right in the most brutal way possible. By the end of 1944, German tank production had peaked and begun its terminal decline. Factories were bombed. Skilled workers were dead or drafted. Raw materials grew scarce. Each Tiger that rolled off the assembly line did so at tremendous cost, requiring resources that simply did not exist anymore. Meanwhile, American factories operated around the clock. 3 shifts, 7 days a week, an endless river of steel and rubber and glass flowing toward the ports. For every German vehicle destroyed, 10 American replacements were already on ships crossing the Atlantic. The battles we remember, the ones with names and dates and monuments, those were already decided before the first shot was fired. They were decided in Detroit and Pittsburgh and Los Angeles, on assembly lines where workers who would never see combat were building the weapons that made victory inevitable. Germany produced approximately 1,300 Tiger tanks during the entire war, masterpieces of engineering, legendary in their power and precision. America produced over 49,000 Sherman tanks, not masterpieces, not legends, just machines, endless interchangeable replaceable machines, and machines are how wars are won. Carl Schmidt survived the war. His report was filed and forgotten, buried in archives that would not be opened for decades. He returned to engineering, helped rebuild German industry, never spoke publicly about what he had discovered in that Italian workshop. But in private letters, in conversations with colleagues, he returned to one idea again and again. The Americans did not ask themselves how to build the best weapon. They asked how to keep fighting longer than their enemies could sustain. Every design decision, every manufacturing choice, every simplified manual and interchangeable part, all of it served that single question. And they built everything around the answer. Why does this matter now? Why should you care about a moment that happened 80 years ago in a forgotten workshop in Italy? Because the lesson Carl Schmidt learned is more relevant today than ever. Look at modern warfare. Look at how drones are reshaping battlefields. Countries with the most sophisticated technology are discovering that quantity has a quality all its own. $1 million missile can be defeated by $1,000 drone. A precisely engineered system can be overwhelmed by simple, disposable alternatives. Look at global manufacturing. Look at how supply chains determine economic power. The nations that can produce more faster at scale, those are the nations that shape the future. Look at technology, at how companies that move fast and iterate constantly defeat competitors obsessed with perfection. The philosophy Schmidt discovered in 1944 now runs Silicon Valley. We like to celebrate brilliance. We build monuments to genius. We tell stories about the single perfect idea that changes everything. But history tells a different story. History says that systems beat brilliance, that consistency defeats perfection, that the ability to keep going, to absorb losses, to replace what is destroyed and continue forward, that is the true source of power. Germany built legends. America built something that legends cannot defeat, a system, a philosophy. An answer to the only question that matters in any conflict, whether military or economic or technological. What can you sustain longer than your opponent? Carl Schmidt understood this, and understanding it broke something inside him that never fully healed. Because he realized, standing in that dim workshop with oil on his hands and defeat in his heart, that the most dangerous weapon is not the one you can see. It is the one that never stops coming.